Imagine a world where energy is harnessed, distributed, and consumed with unparalleled efficiency, where power outages are a rarity and energy waste is a thing of the past. This is the promise of smart grids, a reality that's already transforming the way we live and work. With over 140 million smart meters installed worldwide, the smart grid revolution is well underway. The traditional grid is a one-way system where energy is generated, transmitted, and distributed to consumers without much feedback or control, resulting in inefficiencies and a lack of flexibility. In contrast, a smart grid is a two-way network where energy flow is constantly monitored and adjusted in real time, enabling utilities to respond quickly to changes in energy demand. This is made possible by advanced sensors, known as phasor measurement units, which can detect even the slightest changes in energy flow, allowing for rapid response to grid disturbances. For example, the smart grid system implemented by Duke Energy in North Carolina uses over 10,000 smart meters and 500 phasor measurement units to monitor energy flow and adjust the grid in real time. Similarly, the city of Boulder, Colorado, has implemented a smart grid system that uses advanced sensors and data analytics to optimize energy distribution and reduce energy waste by up to 20%. By leveraging these advanced technologies, smart grids can improve the efficiency and reliability of energy distribution, reducing power outages and energy losses by up to 15%. Chapter Smart Meters, about the anatomy of a smart grid energy management system. Smart meters are the backbone of any smart grid system, providing real-time data on energy consumption and allowing utilities to optimize energy distribution. In the United States alone, over 70 million smart meters have been installed, with companies like Itron and Landis+Gyr leading the charge. These meters can detect energy usage patterns, identify areas of inefficiency, and even detect potential grid failures before they occur. For example, smart meters have helped utilities like Southern California Edison reduce power outages by up to 30%, while also decreasing energy losses by around 10%. Additionally, smart meters have enabled utilities to implement time-of-use pricing, which has led to a 5 to 10% reduction in peak demand during summer months. According to a study by the National Institute of Standards and Technology, the widespread adoption of smart meters could lead to a 12 to 18% reduction in energy consumption nationwide, resulting in significant cost savings and environmental benefits. Chapter Predictive Analytics, about the anatomy of a smart grid energy management system. Predictive analytics is a key component of smart grid energy management, enabling utilities to forecast energy demand and adjust generation accordingly. By analyzing historical data, weather patterns, and other factors such as population growth and economic trends, utilities can predict energy demand with remarkable accuracy, reducing the likelihood of power outages and energy waste. For instance, a study by the National Renewable Energy Laboratory found that predictive analytics can reduce peak demand by up to 10%, resulting in significant cost savings for utilities and consumers alike. Companies like Siemens and GE are at the forefront of this technology, using machine learning algorithms to optimize energy distribution and reduce costs. According to a report by the International Energy Agency, the use of predictive analytics in smart grids can lead to a 5 to 7% reduction in energy consumption, which translates to a significant reduction in greenhouse gas emissions, with over 100 million tons of CO2 emissions avoided annually. Chapter Renewable Integration, about the anatomy of a smart grid energy management system. One of the most significant benefits of smart grids is their ability to integrate renewable energy sources, such as solar and wind power, into the grid. This is made possible by advanced inverters, which can convert DC power from renewables into AC power, making it compatible with the grid. In Germany, for example, over 30% of the country's energy comes from renewables, thanks in large part to the widespread adoption of smart grid technology. Companies like Siemens and ABB have played a crucial role in developing these technologies. According to the International Energy Agency, Germany's renewable energy production has increased by over 50% in the last decade, with solar energy accounting for around 10% of the country's total energy production. The use of smart grids has also enabled countries like Denmark to meet over 40% of their electricity demand with wind power, with the city of Copenhagen aiming to be carbon neutral by 2025. By integrating renewable energy sources into the grid, smart grids can significantly reduce greenhouse gas emissions and help mitigate climate change. Chapter Cybersecurity Threats, about the anatomy of a smart grid energy management system. As smart grids become increasingly reliant on digital technologies, they also become more vulnerable to cyber threats. A single breach could have catastrophic consequences, including widespread power outages and economic disruption, with estimated losses potentially reaching billions of dollars. In the United States alone, it is estimated that a major cyber attack on the power grid could result in economic losses of over $1 trillion. To mitigate these risks, utilities are investing heavily in cybersecurity measures, such as encryption and firewalls, to protect their systems from malicious attacks. Companies like Symantec and McAfee are leading the charge in this area, providing cutting-edge security solutions for the smart grid. For example, Symantec's advanced threat protection solution has been implemented by over 100 utilities worldwide, while McAfee's smart grid security solution has been adopted by major utilities such as Duke Energy and Exelon. With the number of cyber threats increasing by over 50% annually, the need for robust cybersecurity measures in the smart grid has never been more pressing. As we've seen, smart grids are revolutionizing the way we consume energy, making it more efficient, reliable, and sustainable. But there's still much to explore, from the latest advancements in energy storage to the impact of smart grids on the environment. Join us next time as we delve into the fascinating world of energy storage and ask the question, can batteries really power our future? Be sure to subscribe for more insightful documentaries on the latest tech trends.